So guys, today we are going to discuss a small theoretical part coming under grade 10 physics. All right. So that is most of the students they are having the problem related to how to use the equation displacement equal to velocity to time. Displacement equal velocity to time. So D equals V into T. Most of the students are struggling with finding out what type of what sort of motion you have to include in order to find out the answer. So now let's speak from the beginning. All right. So you see, when we are taking the motion, guys, different types of motion are there in a linear path. Since we are speaking about displacement, velocity, and time, let me take only those physical quantities here. Velocity. Velocity, that is the rate of change of displacement. What is the displacement happening for a certain time? What is the certain time here? Unit second, one second. Unit time, 1 second. All right. So this velocity, when we are taking, if the velocity is constantly maintained, uniformly maintained, then it is called uniform velocity. Then it is called uniform velocity. If it is increasing, it is called increasing velocity, acceleration. If it is decreasing from a high point to a lower point, from a higher value to a lower value, if it is decreasing, it is called decreasing velocity, the deceleration. So uniform velocity, uniform acceleration, uniform deceleration. So these three terms I'm going to use in order to explain D equals V into T equation. All right. So let me take it this way. Displacement. We want to find out the displacement. Right. I'm going to divide the motion into two ways. One, I'll mark it. If moving at uniform velocity. So we spoke about this now. Uniform velocity means it's moving at the same velocity. It is moving at the same velocity. The other one is if it is moving at, right? If it is moving at non-uniform velocity. Non-uniform velocity. Non-uniform means not uniform, not the same. So non-uniform velocity I can refer as the changing velocity. The changing velocity. It may be either increasing velocity, uniform acceleration, right? Or else it may be either decreasing velocity, uniform deceleration. Uniform deceleration. So you see, uniform velocity, the same velocity the object is moving, uniform acceleration, deceleration, increasing and decreasing velocity the object is moving. Then how do we find out displacement using both these motions? If the object is moving at the same velocity, it means that each and every second object moves with the same constant, unchanging velocity. So let's say if the velocity is 10 ms minus 1, 10 meters per second, it indicates that every second it moves at 10 ms minus 1. So that is called uniform velocity. So at this point, how do I find out the displacement? Displacement is equal to, I'll write it as a uniform velocity into time. Uniform velocity into time. So uniform velocity, I can take it as V into T. So straight away, displacement is equal to velocity into time. Displacement is equal to velocity into time. Uniform acceleration, uniform deceleration when we are taking. Displacement is equal to, I can't use one velocity since there are two velocities here, starting velocity and ending velocity. Starting velocity and ending velocity. So since there are two velocities here, I have to take both the velocities. I'm taking as mean velocity. I'll take it as mean velocity. This mean velocity should be multiplied by the time taken. Mean velocity should be multiplied by the time taken. So what is mean velocity? Starting velocity u plus final velocity v. I'm adding these both velocities u plus v. And I'm going to divide it by 2. So u plus v dividing by 2 and multiplying by the time taken. So why do we divide this by 2? Because there are two velocities, guys, that we are using up. One is the starting velocity. The other one is the final velocity. It may be either uniform acceleration or else deceleration, whatever. Increasing velocity means from a lower point to upper point, it's increasing. Decreasing velocity, deceleration means from an upper value to a lower value, it is decreasing. So there are two velocities. So I can't use both the velocities at once in my equation d equals v into t. So what I do, both the values I add, and since there are two values, I'm dividing by 2 to get the average velocity or mean velocity. So u plus v dividing by 2 multiplying by the time taken. So this is the displacement equation when the object is moving at a non-uniform velocity, acceleration or deceleration. So two equations here. Summary, if the object is moving at the same velocity, displacement is equal to velocity into time. Displacement is equal to velocity into time, right? And if the object is moving at acceleration or deceleration, then the velocity is equal to, then the displacement is equal to mean velocity into time, u plus v over 2 into t. So this is how we have to apply the equation depending on what sort of motion the question is giving. So if you're gonna use the first equation when the question is depending on the second type of motion here, you will be getting exactly double of the answer if the object is moving from rest or going to rest, right? So remember, first find out what is the type of motion. What is the type of motion? And according to the type of motion, if it is uniform velocity or a changing velocity, you're gonna apply the equation. So you get the correct answer.